Hello and welcome to Selection with Sathi. Today we explore dynamic attributes and properties from Fluent Python chapter 23. We will learn how _getter handles missing attributes, how @property creates computed values with validation, how cached_property gives you lazy evaluation, and how property factories help you avoid repetitive code. _getter is the last resort in Python's attribute lookup chain. When you access obj.x, Python first looks in the instance dictionary, then walks the class hierarchy using the MRO. Only if the attribute is not found anywhere does Python call _getter with the attribute name as a string. This makes it perfect for dynamic attributes like navigating JSON data, building proxy objects, or implementing lazy loading. But remember, _getter must raise attribute error for truly missing names. The @property decorator turns a method into a managed attribute. Decorate a getter with @property, and it becomes a read-only attribute. Add @name.setter to enable assignment, great for adding validation. The beauty of properties is Python's uniform access principle. You can start with a simple public attribute, then replace it with a property without changing any code that uses the class. Under the hood, properties are class-level data descriptors. functools.chad_property is a powerful tool for lazy evaluation. It runs the decorated method on the first axis and stores the result directly in the instance _dict. On the next axis, Python finds the value in the instance dictionary and skips the descriptor entirely. It's a simple O1 dictionary lookup. One important caveat: cached_property is not thread-safe by default. In multi-threaded code, you should protect it with a threading lock. _new and _init play different roles in object creation. _new is a class method that receives the class and returns a new instance. _init is an instance method that configures the object after creation. Most of the time, you only need _init. But _new is essential when you need flexible construction, returning a different type, implementing a singleton, or working with immutable types like tuples and strings where you must set values before the object is frozen. Property factories eliminate repetition when multiple attributes need similar validation. Instead of writing the same getter and setter for every field, you write a factory function that returns a configured property object. The factory encapsulates the getter, setter, and a unique storage name. Each call creates an independent property with its own internal key. For example, a quantity factory can ensure weight, price, and count are all positive, write the logic once and reuse it for every field.
FrozenJSON from Fluent Python is a beautiful example of _getter. The constructor stores the mapping in a private attribute called _data. When you access any attribute, _getter looks it up in the data dictionary. If the value is itself a dictionary, it wraps it in a new FrozenJSON recursively. So you can write feed.schedule.events:0.name instead of feed:schedule:events:0.name. Attribute access all the way down, much more readable than nested brackets. The record class shows the power of _dict update. In the constructor, we call self.double_dict.update passing quarks. This turns every keyword argument into an instance attribute directly. So record with name equals oscon, year equals 2014 creates an object where our .name returns oscon and our .year returns 2014. It's a flexible way to create data objects without defining every attribute upfront. Linked records show at property for lazy cross-references. The event class extends record and adds a venue property. When you access event.venue, the property fetches the linked venue record by its serial number from a shared database or dictionary. The link is resolved on demand only when you actually access the venue. This pattern is common in ORMs like Django and SQL Alchemy where related objects are loaded lazily through properties. Cached_property shines for expensive computations. Our dataset class has a stats property decorated with cached_property. The first time you access ds.stats, it runs the heavy computation, maybe 2.3 seconds to crunch the data. The result is stored in the instance dictionary. The second time you access ds.stats, it returns instantly from the dictionary. No recomputation, no extra logic, cached_property handles everything.
Key tips from this chapter. Use double_getter for dynamic attributes. It's safe because it's called only when normal lookup fails. Start with plain attributes and add at property later. Python's uniform access makes this a seamless upgrade. Use cached_property when the value is expensive and doesn't change. And use property factories to avoid copy-pasting the same validation logic across multiple attributes. For more concept videos like this, download the Selection with Sathi app. Like and subscribe. Thank you.